At the base of Mount Fuji, inside a windowless factory painted bright yellow, industrial robots build other industrial robots in complete darkness. No workers are on the floor, no lights, no heating, no air conditioning. The machines have been running this way for days at a time. The company behind them controls a massive share of the world's computer-controlled machine tools, and its equipment has helped make everything from American cars to iPhones to plastic pill bottles. Yet outside manufacturing, almost nobody knows its name. The story begins in 1946, when a 21-year-old engineer named Seiyu Inaba walked into Fujitsu Shinki manufacturing in Tokyo. Japan was still rebuilding from the war, and Inaba was quiet, focused, and obsessed with machines. In 1955, Fujitsu decided to explore numerical control, a technology that used encoded instructions on paper tape to direct machine tools automatically. Until then, every lathe, mill, and press depended on a human operator turning hand wheels and reading dials. Numerical control promised to replace that physical skill with repeatable instructions. Fujitsu put Inaba in charge of a 500-person engineering team. Within a year, his group produced Japan's first successful electro-hydraulic pulse motor and a working numerical control prototype. In 1958, the team shipped its first commercial NC unit to a major Japanese machine tool builder. During the 1960s, Inaba's division moved from simple positioning to contouring control, which meant a machine could trace complex curves and not just stop at fixed points. That was the leap that mattered. The machine could now carve engine parts, turbine blades, and other complex shapes with program precision. By the early 1970s, the technology had evolved into CNC, and Fujitsu's machine control division had become too important to keep buried inside a telecom company. In 1972, it was spun off as FANUC, short for Fuji Automatic Numerical Control. Inaba, now in his late 40s, became executive director, but he understood that the real power was not only in the brain of the machine, the controller. It was also in the hands that moved raw material in and finished parts out. In 1974, FANUC built and installed its first industrial robots in its own factories. Then, Inaba did something that shocked the business world. He moved the entire operation out of Tokyo and into the forests of Oshino village near Mount Fuji. He said precise technology needed clean air, but the deeper reason was isolation. He wanted distance from competitors, journalists, and anyone who might learn how his machines worked. The compound he built covered huge stretches of forest and contained more than 20 windowless factories and many office buildings. Everything was painted the same bright yellow: the walls, the machines, the uniforms, the company vehicles, even small details in the cafeteria. Inaba liked to say yellow was the emperor's color. The message was obvious. Inside the compound, FANUC operated like a private state. Executives were expected to speak only when asked. Inaba reportedly kept engineers away from outside technical journals, believing they would contaminate original thinking. The company had no public relations office and no investor relations culture for decades. It also resisted email for a long time, preferring fax because Inaba worried about computer viruses. The secrecy became part of the brand. While FANUC was building its fortress in Japan, American manufacturing was entering crisis. By the early 1980s, GM, Ford, and Chrysler were losing share to cheaper, more reliable Japanese imports. GM's CEO, Roger Smith, concluded that automation was the answer, both for quality and for labor costs. The problem was that the US robotics industry was fragmented and underpowered. So in 1982, GM went to FANUC. The result was GM FANUC Robotics, a 50-50 joint venture in Michigan. The partnership was simple. GM brought capital and a customer. FANUC brought the robots, servos, controllers, and manufacturing expertise. A small staff began work in Warren, Michigan, and the venture quickly focused on paint spraying and spot welding. Growth was rapid. Within 2 years, GM FANUC was selling over 1,000 robots a year and had become the #1 robotics supplier in the American market, overtaking Cincinnati Millicron. By the mid-1980s, most of its sales were going directly to GM plants. Walk into a GM plant in the 1980s and you would see the transformation in real time. Human welders were replaced by rows of bright yellow robotic arms, each one repeating the same weld thousands of times per shift without fatigue or deviation. For factory workers, that shift meant a trade disappearing into software. FANUC also developed a higher-level robot programming language called Karel, named after Karel Capek, who coined the word robot. It made robots easier to program and integrate, and it helped FANUC build systems that were harder to replace. The human cost was visible too. In factories across the industrial Midwest, workers saw their jobs disappear as robots took over welding, paint spraying, and handling tasks. The economic pain in those communities was larger than any single company, but FANUC became the most visible symbol of the change. Accidents also made the risks of automation plain. A 1979 Ford factory death, later incidents in Michigan, and a 2023 injury at Tesla all showed that robots made production faster, but also created new dangers for workers still around them. FANUC expanded beyond robots. In 1986, it formed GE FANUC Automation with General Electric and entered the CNC controller business in North America. In 1992, it bought out GM's stake in the robotics venture and restructured it as FANUC Robotics North America. The company now controlled both the brains and the arms of automated manufacturing. It expanded into aerospace, food, pharmaceuticals, and consumer goods. Its robo-drill line, compact vertical machining centers became essential to precision parts production. Its RoboShot became the world's first mass-produced all-electric injection molding machine. Its RoboCut handled wire EDM. Together, these machines covered the core fabrication methods of modern industry. One of FANUC's most consequential downstream relationships came through consumer electronics. Apple does not build its own devices, but the contract manufacturers that make iPhones, iPads, and MacBooks buy enormous numbers of FANUC robo-drills. Those machines carve the aluminum chassis from solid blocks of metal with micron-level precision. In practical terms, the shell of an iPhone is shaped by FANUC equipment in factories across Asia. By the 2000s, FANUC had become a global giant. It shipped its millionth industrial robot in 2023 and its 5 millionth CNC unit in 2022. It claims a dominant share of the global CNC controls market and one of the largest installed bases of industrial robots on Earth. Yet the company's culture stayed unusually closed. It operated with no debt and accumulated billions in cash, posting operating margins that would make any investor happy. That changed in 2015 when activist investor Daniel Loeb of Third Point bought a stake and publicly pushed the company to return more cash to shareholders. The clash was philosophical. FANUC's leadership believed the company existed to perfect technology and protect independence. Loeb argued that idle cash should be returned through dividends and buybacks. The pressure worked. FANUC opened an investor relations function and became a little less opaque, though it remained far more secretive than most public companies. The family remained central. Seiyu Inaba stepped back from day-to-day leadership and eventually became honorary chairman. His son, Yoshiharu Inaba, earned his own engineering credentials, worked at Isuzu, then joined FANUC in 1983. Sent to the US to study injection molding, he quickly developed the AutoShot, the first mass-produced all-electric injection molding machine. That machine became one of the company's most important products. Yoshiharu later became president and CEO, then chairman. His own son now works in the robot division. 3 generations of Inabas have shaped the company. Seiyu Inaba died in 2020 at the age of 95 after spending 74 years with the firm. He had earned top honors in robotics and engineering, and he left behind a company that had been built around his design philosophy. Fewer parts, higher precision, and relentless control of the process. Oshino Village, where the company is based, was transformed by that approach. A large share of the village's population has a connection to FANUC, salaries are high, and the company provides housing, childcare, medical services, and other benefits. The village is unusually self-sufficient because of the tax base the company creates. The lights-out factories continue to run. The company has been producing fully automated equipment in darkness since the early 2000s. Robots load raw materials, machine the parts, unload the finished components, and pass them along to the next stage. A vice president once summed it up simply, "Robots building robots in the dark." That is the logical endpoint of Inaba's philosophy. From the first pulse motor to the first NC prototype, From the GM joint venture to the move into the forest, every step removed a little more of the human variable from manufacturing. Not out of cruelty, but out of conviction that a properly designed machine should be more precise than the hand that built it. The financial results show that the conviction still pays. FANUC continues to post strong revenue and profits, expand its US footprint, and invest in new facilities and training centers. It has become one of the most important industrial companies in the world, while remaining, in many ways, invisible to the consumers whose lives it shapes. What made the company hard to imitate was not only technical skill, but discipline. FANUC treated manufacturing as a closed system in which design, control, assembly, and service all had to reinforce one another. A robot was not just a robot. It was a standardized promise that the same machine in Ohio, Osaka, or Shenzhen would behave the same way when the program began. That consistency made FANUC useful to global customers who could not afford surprises on a production line. The secrecy also served a strategic purpose. By limiting outside visibility, FANUC reduced the chance that competitors could study how it organized its plants, its software, or its robot production flow. In a field where small advantages compound quickly, a hidden process can be as valuable as a better product. The company's yellow factories became a physical expression of that idea. Not a showroom, but a sealed system. At the same time, FANUC's influence spread far beyond its own facilities. Every time an electronics assembler cuts an aluminum case, every time an auto plant welds a body shell, and every time a molder produces a plastic component with repeatable quality, there is a good chance some piece of FANUC hardware is involved. The company does not need public recognition to matter. It only needs its machines to keep running. From a 500-person engineering team inside a telecom company to a global industrial empire hidden in the forests below Mount Fuji, FANUC did not win by being charming or visible. It won with servo motors, source code, and mechanical precision. Whether it is an iPhone shell, a part machined in Michigan after midnight, or a collaborative robot working next to a human operator, the rhythm of modern manufacturing still runs on FANUC's pulse. FANUC's success also depends on the fact that manufacturing today is no longer measured only by how many units come off a line. It is measured by repeatability, downtime, tooling life, and how fast a plant can recover when something shifts. A controller has to survive temperature swings, vibration, bad power, and operator error. A robot has to work through long shifts without drifting out of calibration. Those are the kinds of problems FANUC built its reputation on, which is why the company stayed essential even as the products around it changed. That is also why the company's robots became so important in places where the consumer never sees them. A factory that produces medical devices, phones, molded plastic parts, or automotive subassemblies may look ordinary from the outside, but the machines inside are doing highly specific work at remarkable speed. FANUC's hardware sits in the middle of that system, quietly coordinating motions that used to require a room full of operators. The more standardized the process becomes, the less visible the company is to the public, even as its influence grows. The labor story is more complicated. Automation did not simply erase jobs everywhere at once. It changed what jobs were available, who needed training, and what skills mattered on the factory floor. Some workers moved into maintenance, programming, and line supervision. Others were displaced and never made it back into the industrial middle class. FANUC did not create those pressures by itself, but it became one of the clearest symbols of a world where a robot could outlast a shift and a controller could outlast the person who installed it. That tension is part of why FANUC remains interesting. The company is a reminder that industrial power often hides behind technical quiet. It does not need a loud consumer brand because its customers are other manufacturers. It does not need retail visibility because its products live inside factories. And it does not need a public myth to shape the world because the parts it helps make are already in everyone's daily life. Even now, as collaborative robots and smarter software spread through factories, FANUC's core idea has not changed much. Keep the motion precise. Keep the system repeatable. Keep the process under control. That philosophy began with paper tape and pulse motors, but it still governs the yellow robots moving through dark rooms at the foot of Mount Fuji. That is why the Lights Out factory is more than a gimmick. It is a compressed image of the company's whole history. Every stage of the process has been stripped down to what can be automated, standardized, and repeated without supervision. The building can stay dark because the system was designed so carefully that human presence is not required for routine production. In FANUC's world, darkness is not absence. It is proof that the machine has taken over the routine and left people to design, maintain, and improve the system around it. And that is the quiet achievement behind the yellow walls, a factory built to make other factories run better. That is the real product, precision that multiplies itself. It is an industry hidden in plain sight, quiet but everywhere.